Okay, so if we talk about the optimality, so we can actually compare a few things here. We can actually compare what is the completeness. Completeness means that whether this solution, this algorithm returns a solution to you or not, yes or no. So from here, we are able to get the return path right. As long as you are able to get the return path, for this case, yes. Completeness, yes. You are able to return the solutions. So optimality. Optimality is for branches is are we able to achieve the goal in the shortest or least amount of stations? Because we are not going to use distance, right? So the only information that we have is number of stations. So in this case, how many stations the agent is actually traveled? Yeah, so let's say, yeah, so 1, 2, 3, 4, 5, 6, 7. 7 stations. 7 stations. But if you look at the breakfast search, okay, breakfast search, how many stations? Right, so I'm going to use rule 1, 2, 3, and 4. Only 4 stations. So which one is more optimal? Which one is more optimal? Depth or breadth? Breakfasts. Why? Because breakfast only 4 stations. Just now we will compare to the depth search. The size is the smallest. Okay, so this one's 7. So just now we have only 4 stations for this case, 4 stations. So definitely in this case, breakfasts give you optimal solutions compared to the breakfasts. We are comparing number of stations. Okay, so if you compare with the time, you can also compare with the time and also the space. So usually we have to use a big O notation to compare these two, but we can also use a logic thinking to see how much time is actually spent. Right? For example, if the so-called this one is okay, you may assume that each time the node expand is equivalent to 1 second. So it expand 1 time, 2 times, 3, 4, 5, 6. It's actually expand 6 times. You assume that 1 time is equal to 1 second, so 6 seconds here. How about breakfasts? Okay. Breakfasts expand 1 time, 2, 3, 4, 5, 6, 7, 8, 9, 10. They expand 10 times. So you can assume that breakfasts in this case consume more time compared to the breakfasts. Right? Assume that it's expand 1 time, take 1 second. So this one 10 times, so 10 seconds for breakfasts. So only how many seconds now? We calculate breakfasts. There's only 6 times. So in this case, you can say breakfasts consume less time compared to the breakfasts. How about memory? So memory same things. Each node that we store is equivalent, let's say, 1 byte, let's say. Yeah? So how many nodes that you need to store? Yeah? Store 1 node, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you actually store 10 nodes. So this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If we use link go test, 12. So we can say breakfasts consume more memory. Yeah? No memory means how many nodes that you need to store inside the array, and how much of memory that you will use. So in this case, you can say breakfasts consume more time, more memory, but it is more optimal. Consume less so-called next station to arrive at the destination. So this is what we can conclude. Okay? Yeah. Okay. Okay, so this is the example for the map. So let's move on to the next examples here. The next example is about the puzzle. Okay, so this puzzle there's no state space. If there's no state space, then we got to expand manually. Yeah, not according to the state space anymore. Okay, so in this examples here, so we try deficit first. Deficit is very simple. We try deficit. Okay, so we have 1, 2, 3, 4, 8, 5, 7, 0, 6. And the successor function is already given here. The successor function move the empty tiles according to left, right, up, down. So what you can do here is move the 0 left. Okay, so is this equal to solution? No. Then we continue. Always remember follow one direction, one path. Okay? So again, the moment you go to the next level, so this is level 0, this is level 1. So you move to the level 0, you need to reset the direction. So you move to the according to this sequence left, right, up, down. So you start with the left first, right, in the level 1. So this is not equal to the solutions. Right, so you go to the next level. The moment you go to the next level, so you have to reset the successor function, move to the left again. So 0, we can't move to the left hand side. If you can't move to the left hand side, okay, we shift to the next one, right. Okay, so this one go to the right hand side. But you will find that this is actually same like the initial state. You are basically repeating the initial state, so this is not valid. Repeat the state. So we got to go to other branch, right? Go up. Right. Move up, yes, this is valid. So 1, 2, 3, 0, 8, 5, 4, 7, 6. Okay, so check, is it equal to solution? No solutions. With no solution, what is the next thing? So you need to continue. You need to continue, reset the successor functions, go to the left hand side. Cannot go to the left hand side, then you go to the right hand side. So you go to the right hand side, you give you 8, 0, 5, 4, 7, 6. Then you continue. You continue until you get the solution. Right? So I'm not going to expand all the tree or all the loops for you. So this is actually how it works. You have to expand level by level. So level 3. Is it equal to solution? This is not equal to solution. Right? Go to the next level. So how? Reset again the successor function. Move to the left hand side. Move to the left hand side or repeat the state. Okay, cannot. Then you move to the right hand side again. So repeat until you arrive this state. That's it. So this is references for this problem. Okay, we use kind of a backend search to arrive at the destination. Okay, so how about references? Okay, references. We have 1, 2, 3. This is references. 1, 2, 3, 4, 8, 5, 7, 0, 6. Okay, so we expand all. Right, we expand all. Remember the references side to side. Yes, side to side. Follow this successor function, left, right, up, down. We move to the left, yes, this is valid. Okay, right. Okay, valid also. Up, okay, valid. Down is not valid because you're outside the boundary already. So down is not valid. So this is level 0, level 1. So no solutions, yeah, we check, okay, there's no solution, go to the level 2. Right, so the moment you go to level 2, reset the whole successor function, okay? Move to the left hand side, not valid. Move to the right hand side, repeat the state. Move up, yeah, move up. Okay, and move down. Down also cannot. So there's only up or right. Right cannot, left cannot, down. Okay, there's only one successor here. How about this? Move to the left, repeated state. Move to the right, not available. Move to up. 1, 2, 3, 4, 8, 0, 7, 6, 5. Down not available. So this one you have 3. Alright, you have 3 here. So you can have moving to the left hand side, so valid. 1, 2, 3. 0, 4, 5, 7, 8, 6. Move to the right hand side, also valid.
传染，我知道为
And move to the up. Okay. Still no solution, then you continue. Continue the level 3, level 4, level 1 until you get the solution. Okay? So this is actually how agents work. This is how actually the agent will start to perform the search. Okay, and then you don't need to worry about it. You just need to declare the successor function, declare the initial state, the agent will perform the search for it. Okay? So don't get confused. So this is not actually, we are not the one who expand this, the agents will perform the search. Okay? And I just show you how the agents perform the search from their perspective. Okay? Alright, so okay. Okay, good. So let's move on to the last examples here, which is the cannibals and the missionaries. I think it's not the cannibal, it's a slightly different. Here you have two parents. You have two parents, you have two children here, and you have one fisherman. So we can represent 2 to 1. So you need to move these 5 colors here from the left hand side to the right hand side, but there are some rules. The boat could only carry only 2 persons. No child should be left alone without the supervision of at least one parent. Means that you cannot have children without any so-called parents together, right? The family must get through all the time. The family returns the boat to the fisherman, and only the fisherman and only the 2 parents knows how to row the boat. So these are the rules here. Alright, so again, we have to do some planning. So we need to form our form here. For example, in this case, we put 2 to 1 L000. So represent the left hand side for the parents, left hand side the children, left hand side the fishermen, so the boat position as well as the number of the parents, fishermen, and the children at the right hand side. Okay, then you need to form our initial state, this and that, and the successor function, which is the most important one. It's how the agents will move. So we have 4 actions available to the agents here. We can move one fisherman plus one parent with 1 children, and 1 parent only. Okay? So anyone would like to try this question using, let's say, breakfast search? There is such questions in tutorial using breakfast search. How about breakfast search? I'll show you 1 or 2 levels. So this is how it actually works. So we have 2, 1, L, 0, 0, 0. So the agents will start to move according to this successor function. Move 1 fisherman to the left hand side to the right hand side. So 1 fisherman means that we have a -1 and +1 at the right hand side. So we will have 2, 2, 0, R, 0, 0, 1. So this one is to move 1 fisherman. Okay, so second option here we can move 1 parent, 1 fisherman. -1, -1, right? 1 fisherman, 1 parent. You will get 1, 2, 0, R, 1, 0, 1. 1 fisherman, 1 parent. We can also move 1 parent, 1 children to become 1, 1, 1. R, 1, 1, 0. And only move 1 parent here. So you have 1, 2, 1, 1, 0. So this is only first level. So you have to continue up. So now this is where the boat at the right hand side. The boat is at the right hand side now. So this is level 0, level 1. So you continue up. Alright, so this is how agents perform this. Alright, so I just spent quite a long time to solve it yesterday. I just saw the page. And this is actually how the yeah. So you can see, yeah. So start from here.
完蛋了，我感觉我要 feel 了。
Yeah. So initial state. So generate for state here.
你有没有？
Okay. Again, generate here. Repeat the state cannot. We shift to the level 2. Okay, and then we continue. Right. So this is the solution. The solution is somewhere around here. And the solution is somewhere around here. Can't see it. So this is the solution.
What the fuck is this, man?
Okay. Yeah. So this is the tree lah. This is the tree using the brackets. You can see that I expand. Okay. So this is the solution, and this is how the agent search, and this is the solution. So meaning that we have only moved 1, 2, 3, 4, 5, 6, 7. Then we achieve the solution already. We don't need try and error just like last week. Right? We move for 10 or 20 move. Then we go to reset. So this is how the agent actually solve it, and this is the solution. Yeah, we need to first move one parents, one fisherman, one parents, one children, one fisherman, one parents, one children, one parents, and one fisherman, one parents. Then we can arrive the destination already. Okay. So do you want to have this first question in the exam?
我是牌照不会开灯的。
You want? Depends on performance. If your performance is good, then you're not going to set this kind of question. If you make noise, then I set this kind of question. Okay? Okay, so that's it. So I hope that you have a better understanding of what I mean by the practices and deficits. Excuse me. Yeah, thank you. Alright, so deficits, search one direction. Only one fish. Search one fish, no solution, backtrack, try to search another level, another branch here. Practices, we search level by level. Okay, we search level by level. So all the example I show you just how the agents move on. It's not how the human moving. Yeah, so don't get confused. Okay, so few more slides before we end it. So this is another variation of the depth of first search. So there's one problem with the depth of search here. Okay, imagine you have a very big space. You have a very big space here. So remember depth of search will search only one page. Okay, so although the solution is somewhere around here. So imagine that the solution is somewhere around here. So because of the natures or patterns of the depth of search, you will just follow this path. You will search. Let's say your problem set is very big, then there will be impossible for the agent to search the solution because we will continue to search until maybe trapped inside the finite loops. Okay, so how to solve it? Then we can use this called depth limit search. So instead of let the agents to search until unlimited here, so maybe we can set depth equal to 5, let's say. So the agent will search 1, 2, 3, 4, 5. As long as there is no solution, so we will stop here and then we will go back tracking. Okay, it will just stop at the level 5, for example. That limit, we limit the depth. Okay, but there's a problem here. How to define the depth limit here? So what is the threshold value? So there's no so-called fixed value, and there's no techniques to find a optimal limit here. So there's another problem, another solution that we can use is called iterative deepening methods. So where we will use a for loop to keep opening or to keep increasing this limit. And let's say d equal to 5, there's no solution, we increase. Maybe we add 2 levels. Now becomes 7. 7 still no solution, we add 2, 9. We keep increasing the depth limit here. Okay, and then the last one is just a bi-directional search, just for 2 ways. Yeah, we start from the initial state as well as we start from the goal state. Right, we expand from the initial state and then back so-called the goal state simultaneously until you mix at the center point. As long as you get the center point, then we will start the search. It's called bi-directional search, but it's unlikely that we use the bi-directional search because you need to know what's the goal state first. Okay, so normally we use the central search and preferences. Okay, so far okay. Good. So that's it for today. You have plenty of questions and the tutorial to make sure that you attend the tutorial class. Okay, so there will be a lot of different type of questions for you to answer. Okay, so attendance good. Attendance good. Good.
能呢？
啊？有，以前也是没戴眼镜，也是。
6400054